Hello everyone. Can everybody see me and hear me clearly? Good morning and good afternoon, dono. Very good morning, very good afternoon, whatever suits you. And just don't say good evening and good night because it is not that time. So please share this session, everybody. Good afternoon, very good afternoon. I welcome you all. Already I welcome you with my open hearts. सर आपकी तबीयत सही नहीं हुई? नहीं, अभी तक सही नहीं है, बट सिंस आई फील दैट इट इज़ नॉट गुड टू डिले much more, that's why I came. I'm good, thank you for asking. Okay, so how about it, please start right away, without wasting any further time. Let's start right away. Is it clear? Thank you. Good afternoon. मैं ठीक हूँ, ठीक ठाक सा, ठीक सा. Good afternoon. Okay guys, let's have a look. Let's see how heat transfer is going to unfold and how we are going to talk about it. So the subject in discussion is heat transfer. Now I want everybody, please listen to me very carefully. My dear students. Good afternoon. Love from my side. Please listen to me. So today what I am going to start is going to leave a lasting impact in your lives. Why? Because what we are going to start is definitely going to change the course of history of your life. Let me tell you, when we are doing this heat transfer over here, we are going to see various practical applications, and the entire perspective of yours to view the world in a different way will be possible after the completion of this subject. Okay, each and every topic we'll discuss in much detail. Everything we'll discuss in much detail. Okay, so let me tell you what heat transfer is and why is it different. कितना दिन चलेगा ये मत पूछा करो, जल्दी हो जाएगा. It will be finished as soon as possible. Okay, it will be finished as soon as possible because my commitment towards you is also the completion of subject in a given period of time. Okay students, right? So gate examination 6 to 7 marks, no matter, doesn't matter. How does it vary with thermodynamics? We have already studied thermodynamics, have we not? Yes. And in thermodynamics we had one definition which stated that thermodynamics is a branch of science that deals with the study of energy interactions between system and surroundings. Right? So already we are talking about energy interactions in thermodynamics. We have, yes or no? And out of energy interactions already we know that heat is also a form of energy interaction. Yes or no? We'll see. See everyone, please. Let me give you one quick note point so that everybody will understand. See, there's a problem still going on. Throat problem is there. I don't know how long it is going to last. So whenever I'll feel uncomfortable, I'll stop it. Okay, but meanwhile I will try my level best that we should reach the standard time of 1.5 hours. Okay, standard duration of 1.5 hours. Okay. Yeah, so see, heat transfer, thermodynamics, let's set the differences. So in thermodynamics we have already talked about heat transfer. Heat is a form of energy interaction, energy transfer which occurs due to temperature difference. If there is a temperature difference, there will be heat transfer. If there is no temperature difference, there won't be any heat transfer. Yes or no? We have studied this. We have already studied this. We have already taken it into our considerations. Great. Then sir, why there is a need for heat transfer? Why there is a need for heat transfer at all? Let me give an example for you guys to understand. Please see. Suppose everybody has this habit of having a morning cup of tea or a coffee, right? So this is your cup of tea. In this, you have hot tea, right? Hot tea is there. Okay, this is hot, and the vapors and all, everything. This is hot tea. The temperature, let us say, is 80 degrees Celsius, just an example, and the surroundings temperature is 25 degrees Celsius. Okay, beat in with warm water. I'm doing it, Vishal, but I don't know what the problem is. I've already got myself checked for COVID test and everything, but let's see. See, thermo gives only the amount of, yeah, exactly. Now what I'm going to tell you here is, see, what does thermodynamics tells you? It tells you that when it reaches from 80 degrees Celsius to 25 degrees Celsius, how much is the heat transfer? Okay, how much exactly heat transfer is required in order to bring it from 80 to 25 degrees Celsius? Yes, this is what your thermodynamics tells you, that there has to be some heat which is to be extracted in order to make it reach from 80 to 25. Is it clear? Or in other sense, thermodynamics will also tell you that okay fine, what is the end temperature which you can achieve after complete cooling? After complete cooling has been achieved, how much is the temperature which we are going to get? Bacha, that is 25 degrees Celsius. And if you want to go below 25, you have to provide refrigeration. We have studied already. Yes, if you want to go below 25, you have to provide refrigeration. Yes or no? Without refrigeration, you cannot go below 25 degrees Celsius. Clear? Concept is clear? I think it is. Now let us talk about heat transfer. Here we are much more interested in rate of heat transfer. Right? What is the rate? Rate means amount per unit time. Yes or no? This is amount per unit time. We are much more interested in amount per unit time. What is the amount of heat transferred per unit time, per second, let us say, or per minute, let us say. Okay, so let us say, for example, this is a room and you might see the sweat. Okay, now let's say, suppose I have switched on the AC, air conditioner I have switched on. So there must be some rate at which heat is being removed. And if you remember from your course, right, from your course, you can study, chemical engineers can study as well. Mass transfer is a different topic which is there, which I will not cover, and which you can see separately. Already courses are there. Okay, so don't worry, you can watch heat transfer, you can watch. Okay, anyways, so what is per unit time? Some heat which is to be extracted per second. What is that value exactly? Right? Also, heat transfer will tell you the temperature after, let us say, 5 minutes or after some amount of time. Let's say, for example, it's just an example. Okay, after 5 minutes, 10 minutes. Like, for example, you have taken a hot cup of tea, you have put it on the table in contact with the surroundings, and after 5 minutes, what's temperature? What is the temperature which you are going to get? Right? What shall be the temperature after 10 minutes? What shall be the temperature after whatever, time frame? So after some time, what temperature will be achieved? It will be told by this only. Right? Laws of heat transfer only. Also, how much time to reach, let us say, 50 degrees Celsius. It is also an example. It can be 40, it can be 42, anything. Right? So how much time is taken by the system to achieve some given temperature, or how much temperature will be after a given time? So vice versa thing is there. Right? You can calculate both ways. All in all, let us talk about this once more for the last time. Thermodynamics is the branch of science that deals with the study at equilibrium conditions. Here we are much more concerned about equilibrium. You have one equilibrium state, you have another equilibrium state. So from one to another equilibrium, how much is the heat which is to be sorry, how much is the heat which is to be removed? How much is the heat which is to be removed in order to obtain, the equilibrium state? Here we are not concerned about equilibrium. Here we are totally, devoid of equilibrium. We are not at all concerned about equilibrium. We do not care for equilibrium at all. Got it? That is the difference. That is the basic difference between heat transfer and thermodynamics. Understood, my dear? Understood, my dear, everybody? Say yes or no. Equilibrium, non-equilibrium. Simple. One thing you remember. I have already taught you that in thermodynamics we study about equilibrium. In heat transfer, not equilibrium. I mean, non-equilibrium conditions. Got it? Speaking loud. अरे वो जोश में हो जाता है यार. It happens. Got it? No problem, no problem. Most welcome. Good afternoon. Everybody understood this? Everybody understood this? You please take the screenshot. Also, I'll provide the notes at the end of the class. Don't worry. Please take the screenshot. Please take the screenshot. I think you might have. Okay. Let's move further. So in a nutshell, thermodynamics is the study of equilibrium, equilibrium states, and heat transfer is the study of non-equilibrium states. That is, the rate of heat transfer is important. In this, the important thing is rate of heat transfer, and over here, that is the amount of heat transfer. Amount of heat transfer is important. Okay, so that is the difference. Over here we are much concerned about the amount of heat transfer. In this we are much concerned about the rate of heat transfer. So these are the important terms. Good afternoon, good afternoon. Got it, everybody? In nutshell, in a short thing. Okay. So in heat transfer, what are the modes of heat transfer? Modes of heat transfer. HT, whenever I am writing, I am not saying Hindustan Times. I am saying heat transfer. Okay. Modes of heat transfer. What's the meaning of modes of heat transfer? The methods by which heat is going to be transferred. Okay. What are the ways heat can be transferred? Okay. So in short, I can say ways of achieving heat transfer. Right. So the ways of achieving heat transfer is number one, conduction. We'll study each one of them one by one. Number two is convection. And my dear students, my dear lovely students, number three is radiation. Okay. So conduction, convection, radiation, these are the three basic modes in which heat is going to be transferred. Okay, these are the three basic modes in which heat is going to be transferred. Conduction, convection, radiation. We'll study one by one what's the difference between them and how do these are achieved by a system. Okay. Next, the applications of heat transfer. Applications of heat transfer. Okay, let me tell you the application part. So when I am talking about the applications of heat transfer, number one is your, of course, heat exchangers. Heat exchangers. And in heat exchangers, we include everything. Right? Heat exchangers include condensers. Heat exchangers include yeah, sorry for that. Heat exchangers include boilers. Heat exchangers include recuperators. Heat exchangers include your what is that? Recuperators, regenerators, air preheaters. Yes or no? Superheaters. These are all heat exchangers. Okay. Next, fins. Everything we'll study. Fins. You understand? Fins are there. You must have your bike, motorbike. On the engine, piston cylinder arrangement or the cylinder head, you must have seen these protrusions or extended surfaces coming out of that, coming all over the surface. That is your fin. So fins are there. They are also the examples. We'll study the fins one by one. We'll study 4 different types of fins and every case in a much depth. Insulation of steam pipes. Critical radius of insulation is there, right? Critical radius of insulation is there. Yes or no? So we will study. Please pay this attention. Please pay attention. This is very important. Please pay attention. This is very important, which I am going to tell you. You have electrical wires, right? Electrical wires carry electricity. Also, you have studied in your 10th standard H equals to I squared RT. Yes or no? You have studied this: current, resistance and time. I squared RT. So when we have studied this, due to electricity there is heat also generated. So now see, if you have seen that electrical wire is very thin. If the generated heat is more, that wire may melt or break down. Yes or no? That can happen. That can very easily happen. It's a sure thing, which we can take as an observation. But it doesn't. It never does. Why? ठीक हूँ मैं. Thank you for asking. Good afternoon, buddy. Why? Because of this insulation. So what's the purpose of insulation? Insulation, apart from providing a covering, a sheathing, it also enhances. Yes, it also enhances your heat transfer rate. Got it? In some cases it enhances, in other cases it will provide the resistance to heat transfer. So all this we will study. Okay. Then you have radiation shielding. That's a very, very, very beautiful concept, my dear students. Radiation shielding, that's also an example of it. And yes, this is the most important part: heat pipes. I always say that there are some regions from where questions can be asked. This is one of them. From heat pipes, one theoretical question may be asked. Okay, if not in GATE, then definitely in your engineering services or other state services examinations. Why? Because this is in very, very, very much popularity. I'll explain this in much detail. Okay, so these all are the applications. Baharhal, whatever is mentioned, that is conduction, convection, radiation, heat exchangers, we'll study these. Plus fins also we'll study this insulation, everything we'll study. Everything. Okay, but as a part of these, okay. Please take a screenshot. Please take a screenshot, my dear. Everyone. Okay. Yeah. Now, you want daily PYQs as homework? Huh? Okay. See, I'll give. Okay, I'll give, but not from today. Once we cover some domain, because this is the very first day, and from very first day you cannot consider yourself to be doing all the PYQs. To be able to do that, at least you should have some knowledge. Okay, and so we'll do that. Don't worry. In thermodynamics also I was giving, and we were discussing that on a specified day. So will that be the perfect way forward? I mean, I'll give you that okay, do this chapter, do this much questions, and the very next day or 2 days or 3 days later we'll discuss that. Is that fine strategy? You have the books and all. Is that fine strategy? Everybody? No problem in that? Fantabulous. Let's move on. Let's move on. Modes of heat transfer. Modes of heat transfer. Will not study it by simple definitions and all. Okay? Insulation enhances the heat transfer. Is this a property, or you can say by mathematical term? No, it's a property. I'll explain why. Okay, Narendra? I'll explain why. Explain why. Huh? Let's see modes of heat transfer. है ना? ये मैसेज रिट्रैक्ट कर लो यार सुमित, खुद को शर्म नहीं आ रही? क्या लिख रहे हो? हैं? मैसेज रिट्रैक्ट कर लो, इससे पहले मैं डिलीट करवाऊँ, बेइज्जती हो. मैसेज डिलीटेड आए, इससे अच्छा मैसेज रिट्रैक्टेड आ जाए, वो ज़्यादा बेटर है ना? खुद रिट्रैक्ट कर लो, कुछ भी बोल रहे हो. चलो देखो, मोड्स ऑफ हीट ट्रांसफर. लेट्स टॉक अबाउट इट. Let's understand it with the help of an example. Let's understand it with the help of an example. Suppose this is your college building, right? This is your good Sumit. This is your college building, and this is a building. Okay, fantastic. And your college campus is very good, let us say, and nearby vicinity you have a pond, right? You have a pond in the nearby vicinity. This is pond, lake or pond, right? Now what happens? That someday you went to your college and you saw that your college is on fire. I mean, literally it is on fire. The building has caught fire. Fire, and this is CB. What is CB? College building. Okay. Now you have got there. What will happen? You'll run away? No. Suppose that there's a dream of every, what should I say? Every person by doing brush daily. Oh, काश ऐसा होता, आज टेररिस्ट अटैक होता, मैं ऐसे जंप करके जाऊंगा, टनना नना नना. Yes or no? So this happens, right? This happens. It happens every time. Everybody is dreaming that, and suddenly you get a chance to become a hero, right? So this college building is burning. Now you are the one who's taking a lead, and background music chal raha hai, tanana nana nana nana. What you are doing? You are creating a human chain. You know that there is a pond nearby. You are creating a human chain. Now what will happen? By creating this human chain, you are taking water from here, from bucket to bucket, and you are pouring it this side. Okay? Yes or no? Yes or no? So you're trying to, extinguish this fire by transferring water from that side of the pond to this side by creating a human chain. Okay. First case. Second case, let us say that number of people are not enough. Okay? You are only 2 to 3 people that day. Suppose there's a whole college on mass bunk. So what's happening? In another scenario, you are only 2 to 3 people. Human chain cannot form, but you have to save it. So दिमाग में आइडिया आया, ए तू भाग के जा, बाल्टी लेके आ, मैं भी भाग के जाऊंगा, बाल्टी लेके आऊंगा, फिर करेंगे. Yes or no? So this person, you two are going and doing this. Motion is there. Yes or no? Or there might be a third case scenario as well. Okay, only you are there. So what would you do? लगने दो, जलने दो, कोई दिक्कत नहीं है. ठीक है, आई एम जस्ट गिविंग यू अ सिनेरियो कि बचाना है. ओके, योर क्रश इज वाचिंग यू, देन यू आर डेफिनेटली यू हैव टू सेव. एनीवेज, सो नाउ व्हाट विल हैपन? तब तो कूद जाओगे आग में. नहीं, applied your brain, you connected a pipe, and with that pipe you have connected a pump, and that pump you have made a nozzle, and from here what are you doing? You are simply spraying this water directly. Okay, so these are the three possible scenarios. Fourth can be that you have called a fire brigade, and they are coming and they are doing this, right? They are doing that. So one and the same things. I mean, out of these three, only out of these three, one of the method will be used by you. Yes or no? One of the method will be used by you. So now please pay attention. If you have understood this, you will be, very much familiar. You will become very much familiar with conduction, convection, radiation. How? Please pay attention. Please pay attention. Please pay attention. See, suppose this is one end, this is other end. From one end to other end, the bucket is passing, and the contribution is of each and every person. In the same way, if we have a substance and constituent particles are there, and from one end to another end, the energy is passing through each and every constituent particle. Every constituent particle is contributing in it. That's your conduction. Got it? That's your conduction. Understood, everybody? Simple. Here also the transfer of energy is taking place, but the difference being there is a motion of constituent particles. Constituent particles are in motion. They are in motion, and because of this motion, the transfer of energy is taking place. Observation clear? Over here, there is no role of constituent particles. Still the energy is being transferred. Okay? The energy is transferred in such a way that there is no role of intermediate particles in between. Still the energy is being transferred. Beautiful, right? Yes or no? Yes or no? Now, if you have understood the analogy, let me tell you, this represents conduction. I'm not saying this is conduction. This represents conduction. This represents convection, and that represents radiation. Understood, everybody? This example is the perfect example to understand the nature of conduction, convection, and radiation. In any case, if you try and forget, you won't be able to. Even if you try and forget, you won't be able to. Right? Conduction, convection, radiation. Understood, everybody? Please tell me. I'm asking everybody. Everybody should participate in the discussion part. Tell me, bacha log. This represents conduction. This represents convection. This represents radiation. Simple representation. Okay? How in third energy transfer is taking place? See, the mechanism we'll study. Mechanism we'll study that it is happening due to, transfer of electromagnetic waves and everything. But the more important concern over here is that much pressing concern is that this transfer is taking place without any interference of the constituent particles. The constituent particles are playing no role in it, right? Convection may there is a transfer of molecules or constituent particles. For example, let me tell you, in summers you eat food. You are served with a hot food. Okay, garam garam khana mila. You got the hot food. What do you do? What do you do? What happens? Yeah, there is no issue. Please don't type. Let me explain. Then you won't be facing any problem. Now let me give you one example. Each particle, exactly. No medium is there. See, See, when you are served hot food in summers, you are eating the food, you go in front of cooler or you go in front of, fan or something. So what happens? That fan is a medium and that fan is blowing the air away. And every time the air is blown, that air takes up some heat and then it displaces. It takes up some heat, then it displaces. You understanding? It takes us again in the same way. This is taking the heat from air and it is displaced and taking it away to this side. So heat is being transferred like this due to the motion of particles. Here, the particles are not in motion. Understood now? Understood now, everybody? Understood now? Huh? The particles are in motion in this. Also, you must have seen Babu. Oh, khalo. Garam hai Babu. You do this, huh? Babu khalo, Babu. You do this. So what is happening in that Babu khalo? You are doing convection. How? By blowing the air on the hot roti or chapati or whatever momo you are making your Babu eat. That momo is hot. Okay? So the air surrounding it is also hot. So what is happening? When you are blowing air, the hot air is removed, cold air replaces it, and that hot air takes away some heat. And then again you are blowing, then again some heat is transferred. So there is a motion. There is a motion. Yes, mere babu ne thana thaya. So there is the mothan. Oh, sorry. There is a motion. Yes or no? There is a motion of the constituent particles, which is there, which is represented in this. Okay? Understood? And now, third scenario. You have sun, you have earth. There is an empty space in between. But you are receiving warmth. You are receiving heat from sun to earth. You are getting the heat. Yes or no? There is no medium. In the same way, since each person is representing a constituent particle, there is no constituent particle in between. Right? From one end to another end, heat is being transferred. Understood now? Forced and natural is also there. If you put it somewhere, and there's natural convection also. So that's a part of it. Okay. But convection, what eventually does convection mean? Convection means the motion of the, what do you say? Constituent particles. Okay. So the constituent particles will be in motion. Here, stationary. Here, there is no need. There is no need. Understood, everybody? Now I want everybody to take the screenshot. Even if you don't, I'll provide it at the end in my Telegram channel, like I always do. Is it done, my dear? Is it done? This is a representation part. So from here you must have taken some of the feelings. Now what I am going to teach you is going to blow your mind now. Please pay attention. See, conduction. Let's start them one by one. Yes or no? Let's start them. Let's just start them one by one. Let's start with conduction. Am I right? Let's simply start with conduction. What is conduction? Each and every molecule, each and every constituent particle is taking part in the transfer of heat. Okay? So this explains that it is simply a transfer of heat from one medium, from one end of the, sorry, my mistake, from one end of the medium to the other end, okay, from one end of the medium to the other end, right? Transfer of heat from one to another, in which all the intermediate constituent particles are taking part. ठीक है? In which all the intermediate constituent particles are taking part. Okay? Is it clear? Fastest is radiation. Fastest is radiation. Okay? I've told you, na? Electromagnetic waves, speed of light. That is fastest. Anyways, so transfer of heat from one end of the medium to another end, in which all the intermediate constituent particles are taking part. This is the core, basic surface definition. But let's go into the depth of it. Okay? Let's go into the depth of it. So, this medium, let me explain it to you. Medium can be solid, liquid, or gas. Many people are confused. Sir, gas में conduction कैसे होगा? Sir, in gas does conduction happen? Sir, how does conduction happen in gas? Sir, why conduction we do not consider in gas? Or is it negligible, or is it not happening at all? Now let me tell you a few things. Let me give you a few examples by the help of which you will be able to, certainly get the notion of what I am trying to tell you. For example, suppose you have this stove, okay, and there is water. Okay. Now if you are heating this water, you are giving in some heat. Let's say del Q amount of heat you are giving. Okay. In another case, same beaker. In this you have provided a heater which is merely touching the surface. Okay. This is electric heater, which is merely touching the surface. Okay. Okay. Now you are very late, dear. You are very late. The last date was 4th, so the time is already up. So there is no need of going into the arguments that I want to join or I don't want to join. So don't worry. The time is up. Please enjoy the crash course. Anyways, so this is the electric heater and this is the burner, let us say. So what's the difference between them? Let me tell you what is the difference between them. In this, what is happening? Conduction is there plus convection is there. Both is happening. But in this only conduction is there. So now what happens? What happens? In this, the water, liquid, in contact with hot surface. See, there is a layer of liquid which is in contact with the hot surface. Yes or no? There is a layer which is in contact with the hot surface. Okay. Its temperature will increase. If its temperature increases, density will decrease. Definitely. If temperature increases, density will decrease. We know this already. If that happens, my dear, what will happen? Molecules, they start moving up. They start moving up. Okay? And the heavy molecules, they start coming down. Say yes or no. The heavy molecules, they start coming down and the lighter molecules will start moving up. This happens, yes or no? This happens? Yes, this happens. Right? So in a sense, in a way, the hot molecules are moving up and they are taking up heat. So there is a motion of particles. Conduction plus convection. That's why I have said. Right? There is a motion of particles. Hence conduction and convection. Please open your brains and study the whole physics behind it. Then only you are going to enjoy the subject. In this, see, liquid in contact with hot surface, which is the heater, is heated, means temperature increases, density decreases, but it cannot go above. Hence, no convection, only conduction. Therefore, this is a very slow process, whereas this is a fast process. Got the feeling? Conduction is, you might have observed in a swimming pool, the uppermost layers are hot, but the lowermost layers are cold. Yes or no? Why? Because the conduction characteristic or the conduction property of the liquids is very less than solids. Yes or no? Is very less than solids. Is it clear? Is it clear, everybody? Why? Why? Because see, in liquids we want convection to happen. In gases also same characteristic is there. Motion is important. If the motion is happening along with heat transfer, then the heat transfer will be quick. Okay? Otherwise conduction is insignificant. It happens, but is insignificant. Understood, everybody? Understood, everybody? So there's a fine line between happening and not happening, right? Between happening and being negligible. Got it, everybody? Got it, everybody? See, in this conduction, see what is happening. This is the hot surface, and nearby it we have a liquid layer. This liquid layer, nearby it will get conduction. Conduction is happening. Okay. Because of this conduction, this temperature increases. Temperature increases, density decreases. Density decreases, it will start moving up. And since it is moving up, its place is vacant. Heavier molecules will come down. So there is a motion of particles. Convection is happening. But in this also, the temperature is what? The temperature increases. Density decreases. But it cannot go above this. Yes or no? I mean, it can boil and it can, convert into vapor. But the liquid as a molecule cannot move. So hence, this will first get hot. And then the other layer will get hot due to conduction. So this will take more time. It will take less time. Understood? Is it clear? Yes or no? Plasma, I will tell you while studying radiation. Don't worry about plasma right now. We'll take care of plasma, and I will also explain Bose-Einstein condensate, but not now, at the time of radiation. Okay? Everybody understood this concept? Say yes or no. So what I am trying to tell you, conduction happens in solids and fluids both. Fluid means liquid and gases. Conduction happens in fluids and solids, both of them. Right? But the rate of conduction in solid is very high, and that in liquids is negligible, we should say. Got it, everyone? Say yes or no. Got it, everybody? Say yes or no. Understood? Understood? See, thermos flask is there. You might have seen that the size of thermos flask is this much. It is very large. Okay. And if you see, it stores very less amount of hot milk or hot water or whatever you are storing in that. Its capacity is less. Its size is more. Why? It is double glass coating. Glass coating is double. In the one layer of glass, another layer of glass, and in between there is air. Air is there. So what happens? Because air is a poor conductor, heat conduction is less. Heat conduction rate is very, very, very less. Hence, it can store the fluid or the liquid at the stored temperature for a long duration of time. Understood, everybody? What are you guys doing? Are you sleeping already? My throat is very, very, very sour by shouting and explaining it to you, and you guys are not responding. This is not the way. Please tell me, you understanding these practical examples? Say yes or no. These are real life examples. I have told you already that I'll explain them to you with the help of real life examples, which is very important. Okay? Shall we? Fantastic. So, this is it about conduction. So, let me tell you, take the screenshot. Take the screenshot. Take the screenshot. So, sir, air is a poor heat conductor. by conduction mode only. Yes, air is a very poor heat conductor, very poor conductor of heat. We'll in the upcoming classes, I think tomorrow only, I'll introduce you to a new term known as thermal conductivity, and in that thermal conductivity you will get to know that the thermal conductivity of air is very less, right? Habit gadbad ho gaya. Air is a good conductor while convection mode. Yes, if you have forced convection, then air is a good conductor, right? Air, air can remove heat or it can supply heat at a greater rate if you have convection along with it. Okay, so I should say conduction predominantly is prominent in solids, whereas in liquids and gases it is not much of importance. I'll tell you why once more. Just I've given you the feeling, I'll tell you the real mathematical reason behind it. Okay? Yeah, you can say that. Got it? Got it, everyone? Okay. Now let us talk about this conduction in solids. Okay. Wait. Let me explain this to you. And after getting this, you will be, you'll be like Hulk, screaming in joy. Please pay attention. Each one of you, do not write anything. Okay? Let me give you an example. For example, you must have seen that tawa, frying pan, right? That pan is there where you make chapatis or rotis. Frying pan, tawa is there. So you have that tawa, okay? That tawa is made up of metal, right? So that metal is supplied with a wooden handle. Why? Because if you touch that metal, you'll instantly feel, oh, it is very hot. Yes or no? So there are some solids in which conduction is very fast. Whereas when you are providing the wooden handle, or you must have also, if you have been in some campfire or something, so you have people have that, long log is there. With that log they are constantly stirring and changing the position of the burning wood, so that the wood is burning very easily. But in doing so, they are not experiencing any hotness in the handle, in their hands. Sorry. Why? Because it is not, the conduction is happening, but it is not very dominant as in case of metals. Okay? So there are some solids in which conduction rate is very fast. There are some solids in which the conduction rate is not so, fast. Not so fast. Understood? Observation clear? Observation clear? I'll give you one more observation, so as to establish the analogy. Okay. In India is a country of innovations, not inventions. हम जुगाड़ पे चलते हैं, right? India is running on जुगाड़. So many a times what happens, for example, this plug, if plug is broken, let's say there's a plug, let's say for example, there's a plug, okay? This plug is broken, okay? And sometimes what happens, there's a small plug, we open it, we take out the wires, we break the wires into two, separate them, green and red, and then we insert them. Yes or no? And to hold them into the position, we are inserting the matchsticks. Many people do that, and in villages it is very common. It is dangerous though, but it is common. And while inserting them we are not getting any electric shock. But if we were inserting, let us say there's a all pin or safety pin, you'll get instant shock. Yes or no? You'll get instant shock. Is it clear? You'll get instant shock. So in metals, there is some phenomenon which is dominating the conduction. There is at least something which is there, which is happening, due to which the phenomenon of conduction is very much dominating. Yes or no? And in non-metals, there is something which is absent with respect to metals. है ना? समझ में आ रहा है? मतलब metals में, in case of metals, there is something, we don't know what as of now. Yeah, don't try this at home. Exactly, don't try this at home. Yeah, in metals there is something happening due to which the rate of conduction is more, and in non-metals there is something which is absent due to which the rate of conduction is not that much dominating. Exactly, free electrons. That's the basic difference. That's the basic difference between a metal and a non-metal. Yes or no? So what I can say is, ये मॉस्किटो बैडमिंटन से कंडक्शन के कारण पेन की पॉइंट खराब हो जाती है. मॉस्किटो बैडमिंटन, हाँ बिल्कुल सही. Understood everybody? Understood everybody? So the basic difference is presence of free electrons. So conduction in solids can occur due to, number one, free electron movement from one end to another end. Okay, because see, solids are also metals are also solids, non-metals are also solids, so there is a possibility of free electron movement. If free electrons are there, for example, if we have metallic solid, free electrons will be there, and due to that free electrons being present in that, the free electron movement will be dominating and conduction will improve by many factors. Okay. Number two, lattice vibrations. This is very important. Lattice vibrations. So we have talked about metals, but what about non-metals? See, non-metals don't have this free electrons, so hence there will be no free electron movement, but there is some conduction of heat. There is some conduction of heat. I mean, there is some, बहुत ज़्यादा नहीं, बहुत तेजी से नहीं, but there is some. Why is it happening? It is happening due to lattice vibrations. Is it clear? Is it clear? Let me explain this lattice vibrations. Lattice vibrations in solids. You guys are going to enjoy this like anything. Please trust me. Lattice vibrations in solids. And like this you might not have understood anywhere. So please pay attention. Double attention. See. Suppose this is a lattice. Lattice consists of many molecules. Doesn't it? Say yes or no, my dear students. It consists of many molecules. Many different molecules are there. I am just taking these molecules into account. Okay. I'll do the study on one molecule and you can extrapolate the results on the other ones. Got it? See. Now, what is happening? You are supplying some heat. Let's say you are supplying some heat. And in supplying some heat, I am studying that impact of heat supply. There is heat supply. The impact of heat supply on this molecule. Okay, I am studying the impact on this molecule. Now what happens? When the heat is supplied, it takes on that energy. The energy is supplied to it. Yes or no? The energy is supplied to it. So upon taking that energy, it becomes excited. Once you get something, sorry. My mistake. Oh God. Yeah. So upon taking some energy, it becomes excited. Like you have studied some concept, new concept, you become excited. इधर भागोगे उधर भागोगे, अरे बाप रे, ये समझ में नहीं आया था, आज समझ में आ गया. Now I have understood. Yes or no? Now I have understood. So now you have understood this. Yes or no? Now you have understood this. You become excited. In the same way, it takes on heat. It becomes excited. When it becomes excited, it tends to change its position. Yes or no? When it becomes excited, it tends to change its position. It tends to change its position. Because in 12th standard, you have studied for every given positional arrangement, there is always one what mean energy level. If the position changes, energy level changes. If the energy level changes, the position has to change. Yes or no? So for this arrangement, the energy level was something, but if the energy is increased, energy changes, the position will change automatically. Yes or no? So it tends to change its position. That's great. This tends to change its position, my dear. Okay. The moment it tends to change the position, see what happens. What happens? The moment it is trying to jump over this, what happens? It tries to jump over this, the adjacent molecules. When it tries to jump over the adjacent molecule, it has to go near that molecule. It tries to jump. But the moment it tries, it experiences two very strong forces. It experiences two very strong forces. Number one, attraction. Number two, repulsion. Okay? Two very strong intermolecular forces. Two very strong intermolecular forces are there. वो तो इलेक्ट्रॉन के लिए था, ये तो अलग है ना, पूरी लेटेस्ट. हाँ वो तो पूरी, मैं इलेक्ट्रॉन थोड़ी बोल रहा हूँ. आई एम नॉट सेइंग इलेक्ट्रॉन, आई एम सेइंग द मॉलिक्यूल. Arrangement will tend to change, na? Not talking about the electron, talking about the arrangement. The arrangement will tend to change, na? Because this arrangement, for this arrangement, there is given attraction and repulsion. That attraction and repulsion is fixed. So the moment it tries to alter the, domain, tends to shift the domain or tends to shift the arrangement, very strong forces of attraction and repulsion are observed, and due to which what happens, they bring it back to its position. Okay? They bring it back to its position. So idhar se to nikal nahi paya, it was unable to go from there. Now what does it do? It tries to do the same from here. Same again also. It will experience the same forces, attraction and repulsion. They will make it sit to its mean position. So in a way, it is vibrating. It has started vibration about its mean position. It has started to and fro motion. It is trying to alter the position. It is trying to change the arrangement. But It is being brought back to its initial state by attraction and repulsion. From nowhere it can alter the, arrangement. From nowhere it can do that. Hence it is trying to change, but it is not happening. Therefore, the lattice vibrations will start. Understood, everybody? Understood, everybody? Now, about electrons. See, in case of electrons, these are the lattices. Okay? The size of lattices are larger and the size of an electron is small. This electron can pass from anywhere. Okay? So we are not concerned about the free electrons because the size is less. It can pass from anywhere. If energy is supplied to this electron, it takes up the energy, it will pass from anywhere. But what about the lattice itself? So the lattice will try to change its position, but it cannot because of these. Hence, it starts vibrating, and this will happen to everyone. This will happen to everyone. Yes or no? Got it, everybody? Feeling aaya ya nahi? You understood the feeling? Many a times you might have heard about lattice vibrations, but why lattice vibrations are happening? Why is it that the lattice vibrations occur at the very first scenario? They are happening because of these attraction and repulsion forces into picture. Okay? Understood, everyone? Understood, everyone? Huh? Omkar? समझ में आया नहीं? Got it, everybody? अच्छे से, feeling के साथ. So this is how we'll carry on this. Please take the screenshot and we'll wind up conduction introduction today because great. हाँ कृष्णा, आई नो, भाई की आइडिया ये, आई नो इट. Oh God. Is it done, my dear students? Is it done, my dear students? Okay. So, acha, you want more feeling? You want more feeling? Let me give you. See, for example, you have a cycle. Okay, your cycle is, it is not properly functioning. So you can take your bicycle and you can keep walking. You can push your bicycle easily. Yes or no? It requires very less energy. But for example, you own a truck like Optimus Prime, and your truck Optimus Prime is suffering a malfunction. Can you push it on your own? Of course not. Of course not. Huh? In the same way, there is something known as inertia. The mass or the inertia of lattices are very high with respect to electron. So, they require a threshold amount of energy to at least start vibrating. Yes or no? And if we supply high energy, then only they will start vibrating by large amounts. Yes or no? But these, even if you supply small amount of energy, free electrons, zoop, 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 they will start doing that. Yes or no? They will take energy, zoop, zoop, zoop. Yes or no? Apart from that, although the lattice vibration is occurring in them also, but the free electrons are very fast, at a very fast rate they are transferring heat from one end to another end. Yes or no? So what I believe that the conduction due to free electrons is very, very, very significant or very, very, very dominating with respect to heat conduction due to lattice vibrations. Understood? conduction due to lattice vibrations is not that much of dominating with respect to this one. Understood? In a way, yes. In a way, yes, Omkar. But macroscopically, when you are supplying energy, the positions of internuclear forces are coming into picture, hence it is happening. Got it? That means mass is inversely proportional to vibration. You can say that. You can say that. Inertia is there, no? It tries to be at its state. External energy you are supplying. Okay. So if mass is more, it will require more energy to do so. Got it? Is it clear? So I should say that free electron movement is much more effective with respect to lattice vibrations in terms of heat transfer. In terms of heat transfer due to inertia. Now you can connect the dots on your own as well. Therefore, metals or metallic solids conduct heat at a higher rate than their non-metallic counterparts. Understood, everybody? Understood, everybody? Now you must have got the feeling. Okay? Understood, everybody? Maza aaya nahi? Next. In liquids and gases, conduction, you don't have lattices there, neither you have free electrons. So in gases and in liquids, you don't have lattices. There is no lattice, so there won't be any lattice vibration. Also there is no free electrons, so there won't be free electron transfer. Then how in gases and liquids conduction is happening? In gases and liquids, conduction occurs due to molecular collisions. Okay? Now, please apply your brains, please apply your common sense. But sir, graphite is an exception. No, not only graphite. The exception is graphite, the exception is diamond, the exception is quartz as well. Okay? But that we'll study when we are, studying thermal conductivity. Okay? We won't study exceptions here. I'm just telling you the general trend. Right? I'm just telling you the general trend. Exceptions are there. Diamond is there. Graphite is there. You have this quartz. Right? But why the exception is there? I'll tell you that also. But it's not the right time. Okay? Don't worry. Tomorrow we'll deal with everything. Now please pay attention. In liquids and gases, conduction occurs due to molecular collisions. Why? Because neither there is free electrons nor neither free electrons are there nor lattices. Okay? Nothing is there. If there is nothing, it will only occur due to molecular collisions. Yes or no? Also, in liquids and gases, molecules are farther apart at a distance than solids. Therefore, conduction, see, if I talk about the order, conduction in solids is more than conduction in liquids and then it will be further, it will be least in gases. In gases the conduction rate is very less. Why? Because the molecules distance between them is very large. Yes or no? The distance between the molecules is very large, that is why. Understood everybody? Say yes or no. फीलिंग आया या नहीं यार, ये बताओ. ये सिर्फ कंडक्शन है. What is there is Genisser gas, will it be due to both? Yeah, these are the exceptions yaar. These are the exceptions. Getting my point or not? These are the exceptions, right? Ionized gas, plasma, these are the exceptions. I told you that whenever we are going to talk about, exceptions, they'll be covered in a separate domain. Okay? Understood everyone? But general trend, do you follow the general trend? Solids, liquids and gases. And in solids also, there is metallic, and then there is non-metallic, then liquids and then gases. Okay? This trend is very important. This trend is very important. Okay, please take the screenshot. Maza aaya? Good. Everybody take a screenshot, please. Great, my dear students. I think you might have. Okay, so we'll keep our discussion till now only. Started to face problem. So thank you so very much. I hope you all enjoyed. Power plant के लिए R Yadav is good. You should buy R Yadav. That's a very fantastic book. Okay. So today we were there. I mean, 30 odd students were there continuously. I'm very thankful to you, and also I'll be very happy if this trend continues. I want everybody to come live and watch it. Okay. Thank you so much, Krishna. Everybody, thank you so very much. Love you all. Please share this session as much as possible. Okay, we'll cover it in very, very, very easy manner. Understood? And those who were not able to, join the smart course, don't worry. I'll be teaching here everything in much detail. Number of days. क्लास कब से होती है? बहुत जल्दी कर लेंगे यार, टेंशन मत लो. 2 बजे से. Every day the class is on same channel. Subscribe it, and you'll get the notification. It is always at 2 p.m. Be there at 2 p.m. I don't know the number of days, but soon, very soon, because I have this pressure to complete the syllabus as well. At the same time, I don't want to leave any topic behind. Okay, so please share this session as much as possible. Do like it. Do give your comments as well. They are also very valuable to me. You in all are very valuable to me. And one more thing I want to add up. Let me just give me 1 second. No, not 1 second. A few seconds. Yeah. So my dear students, this is my Telegram ID, right? This is my Telegram ID. Telegram ID, or you should say Telegram channel. You can just join me on this Telegram channel. है ना? Okay, thank you so very much. Love you all. Take care. Engineers talk. Acha, I will also provide this these notes on this channel, so join it. How much time this? It will not take much time. Okay, क्लास खत्म होने वाली, उसके बाद कौन सा सब्जेक्ट स्टार्ट होगा? आदित्य सर बताएंगे. वो संदीप, आदित्य सर बताएंगे. सर 555 वाली स्टार्ट होने वाली है कॉम्बो सीरीज या नहीं? यूट्यूब पे लास्ट टाइम में होगी भाई, होगी. सब पता चल जाएगा आपको. ठीक है. इंजीनियर स्टॉक विल कंडक्ट. थोड़ा सही हो जाऊं यार, अभी बोलने में तकलीफ है, सांस फूल रही है, लेकिन अब आप लोगों से मिलना था इसलिए मैं आ गया, और डिले करना सही नहीं था. In the needed data in arranged form, but in ESE we are given jumbled data and make. Is this difference? There is no difference. Once you start practicing the questions, you'll get the zest. Okay, you'll get everything sorted out in your head. Okay, bacho. So please allow me to leave. Thank you so very much. Love you all. Do take good care of yourselves. Bye bye. Jai Hind. Please, last time I'm saying, share it as much as possible. Love you, my dear students. Oh God.